Now for workshop 9, we're going to look at creating a new scenario for our develop case, where we're going to adjust some of the land use data for our development site. Then we're going to run the scenarios and examine the new outflow, for which we can then determine what size storage we need to maintain the current peak flows. To begin, we're going to create a new scenario. So I'm just going to close the statistical reports. Geez, that word's really getting to me. We press the create scenario icon, and in our new scenario name, we're going to go developed. And select OK. It is always a good idea to ensure that we're working in our developed scenario. Any changes that we make to our base model will be represented in our scenario. However, any changes we make in the developed case will not be represented back to the base model. Now we're going to use a stored query to automatically populate some data for a new land use. So from the transportable files, we open up the RAFTS parameters, and we're going to drag on the stored query, create new land use. Before we do that, if you wish, you could right click and open to view the text in the editor. So dragging on that new SQL, we're going to get a new window which is going to prompt us to enter in some new data for our new land use. We're going to call this new land use urban. We're going to set the percentage impervious to 60%. Our initial loss is going to be 8 millimeters with a continuing loss of 2. Our roughness is going to be 0.035. And for our impervious surface, we're going to set the initial loss to 1. And our Manning's roughness is going to be 0.018. Once we have entered in the data, we will select OK. Now we want to set the subcatchment C4 to apply this new urban land use. So double click on the subcatchment for our development site to bring up the properties window, or alternatively, we can use the properties icon. Select subcatchment C4, and from our land use ID, we want to select from the drop down and choose urban. We're going to leave our subcatchment slope as is for this particular example. It is always a good idea to check your updates in a model after using stored queries. So we're going to check that our land use for urban has applied the properties that we entered in our prompt window. So to do this, we can open up the land use ID for urban from our properties window by right-clicking on the drop-down and opening land use urban. Here we can see that it's applying 60% of our impervious type, and it's applying our 1 millimeter initial loss, and it's got our new Mannings. We can use the back key to then open up the runoff surface 3, which is the pervious runoff surface that we entered in our prompt window. Another way you could view the land uses is by creating a new subcatchments window, and you can navigate to the land use tab down the bottom. A useful tip in ICM to hide any of the tabs that have irrelevant data for a particular project, you can right click and select hide empty tabs. Here you can see under land use for our urban, the percentages of the runoff surfaces applied. You could also view the runoff surface tab to see the results. Once we're satisfied that the model is correct, we're going to validate and commit the changes. So I'm just going to close out the grid windows, go back to the master database, commit the changes. I'm going to add a comment, workshop 9, added, developed scenario. Hit OK, and I'm going to validate the new scenario. There's no errors, so the new scenario should be fine to run. I'm going to create a new run object for the developed scenario. Another way to quickly do this is by double-clicking on our previous run object, and any information that's changed in here when we click Run Simulation, apart from updating to latest, will automatically create a new run object in our model group. So I'm going to change the name here to Urban Development Post Run. I'm going to make sure I update to our latest committed version, and I'm going to check on the developed scenario. Once that is complete, I'm going to keep the time step parameters the same and just run the simulations. It shouldn't take too much longer, though we do have a few storms to work through. These storms are being simulated relatively quickly. Once they're complete, we check all the storms have successfully finished, and then we're going to run the statistics for the post-development scenario. To do this, we're going to go to Results, Statistical Reports, and this time we're going to drag on the post-development runs and the same statistics template. We can use the same statistics template as we haven't changed any of the dimensions or properties to our channel upstream.1. Produce the report, and then we're going to go across to the ensemble summary. And similar to what we did before, we select one of the downstream flows for our 1% event, go to Statistics, select Export Ensemble Box Plot, and we're going to save it as the default with post at the end. Press Save. And we're going to turn on the mean and show the mean marks. I'm going to bring up the results from our pre-development run. Here we can see that the critical duration is still 25 minutes, and we only have a small increase in flows of around about 200 litres per second. In this case, we might not need to add any storage to our development to account for these flows, but for the purpose of this tutorial, we're going to go through those steps in Workshop 10.